Alright guys, we're going to talk about the Unit 1 review. We're going to talk about rational and irrational. So if you remember, rational is a number that can be written as a fraction. Is a number that can be written as a fraction. Okay, so whole numbers, fractions, repeating and terminating decimals, and then perfect squares and perfect cubes. And then what's not non-terminating or repeating, non-repeating, non-terminating, non-repeating decimals, and then non-perfect squares or cubes. Perfect squares or cubes. And then remember, pi and e are two known ones. The sum of a irrational and rational number is always irrational. The product of a non-zero rational and an irrational number is always irrational. Remember, if you have irrational in the problem, it's going to come out irrational unless it's multiplied by 0. The sum or product of a rational number is rational. Okay, so that's part of that you need to know. Then we need to be able to simplify. So if you remember, the numbers that we use for simplifying are 4, 9, 16, 25. These are the perfect squares, 36, 49, so on and so forth. Now we can break this down to 3 times 100 times 7. The square root of 100 is 10. Square root of 7. So that will leave us 30 square root of 7, because 7 cannot be broken down. Okay, here, these have the same radicals, so 3 plus 4 is 7, and then the radical of 6. We would need to simplify this first, so we have 7 square root of 5. We can break this down using 25, so that'll be the square root of 25 times 5. So that'll be 7 square root of 5 minus 5 square root of 5. And notice those two have the like radicals. 7 minus 5 is 2 square root of 5 for our final answer. Okay, when you multiply, they do not have to have the same base. Add or subtracting, they have to have the same. Multiply, do not. So here, I can multiply 4 times 1 times 1 and give me 4 on the outside. 2 times 3 is 6, times 5 is 30. Now I'd want to check 4, 9, 16, all of those won't go, so that would be my simplified answer. Okay, so let's move down to precision and accuracy. A quantity that is precise or approximate. When approximate quantity is used, it's important that we consider its level of accuracy. A dosage of medicine. Is precision important there? Yes. Yes, precision is important there. So that would be yes. We need exactness there. Distance from the house to the mall, does that need to be exact? No. We could say it's about 5 miles. Okay, unit conversion and dimensional analysis. When converting any types of units, you may need unwanted units to cancel out and wanted units to remain. So if we're converting 309 yards to feet, 309 yards to feet. So I'm going to extend the page. So we have 309 yards. So the yards here, because whatever's on top goes on the bottom, and then feet, how many yards are in a foot? We know 3 feet is in 1 yard. That cancels. So that's going to give me 927 feet. So that's going to be 927 feet. Convert 45 miles per hour to feet per minute. So we have 45 miles per hour. So the miles is going to go to feet. So miles here, feet here. How many miles? Feet are in a mile? 5,281. The miles cancel, and then I need to go to hours to minutes. So hours, minute, hours cancel. There's 60 minutes in 1 hour. I multiply across the top and divide by 60, and I get 3,960 feet per minute. When Justin goes to work, he drives an average of 65 miles per hour. It takes him 1 hour and 30 minutes for Justin to arrive at work. His car can travel 25 miles per gallon of gas. If gas costs $3.65, how much money does Justin spend on gas to travel to work? So first of all, we need to take the 65 miles per hour and change it to the miles to work. So we know it's 1 hour and 30 minutes, so we can multiply 65 times 1.5 hours, so 1.5, because 30 minutes is a half hour. We're going to get 97.5 miles to work. Okay? Then we're going to need to do some conversions. Okay? All right, so we know we're driving 97.5 miles to work, and his car travels about 25 miles per gallon. So we're going to take these miles and we're going to divide it by 25, because that's how many miles per gallon, and that's going to give me 3.9. Okay? Now we're going to take the 3.9, and gas costs 3. That's how many gallons we're going to need. It's 365 per gallon. So we're going to do the 3.9 times 3.65, and that's going to say it's going to cost him $14.24 to get to work. And that's one way. Okay, continuing on, we're going to look here at a term, a factor, coefficient, and a constant. Okay, so if you remember, terms are parts of an expression. So we have 2 terms here, 3x and 5, and then this 5 is a positive. A factor, what is being multiplied together? So this is 5 times x to the third, and this is negative 2 times x times y, and then this is just 1. Coefficient is the number in front of the variable. Constant is the term that contains only the number and it does not have a variable. So we have negative 2 and 5 because there's no variable there. So here, identify the terms. So the terms will be 5x squared, negative 3x, and 8. The coefficients will be, remember the coefficient is the number in front of the variable, 5 and negative 3, and then the constant is 8 here. Okay? Identify the greatest common factor in this expression. Okay, so 3 will go into all of those terms, and then 3x's, 2x's, and 1, so 3x is that, and then remember we divide, so that would give me x squared plus 2x minus 5. Now the GCF is 3x. Okay, so let's talk about classifying. In number of terms, 1 is a monomial, 2 is a binomial, 3 is a trinomial, and 4 is a polynomial. If we talk about the degree, when it's 1, it's linear, makes a straight line. 2 is quadratic, makes a U-shaped graph. 3 is cubic, and 4 is quartic. And then 5, if you remember, is quintic. All right, when you're multiplying, you're going to multiply and you're going to get 2x cubed because we're going to distribute, and we add exponents, 6x squared minus 8x. Okay, here we can use the box method, or we can distribute and get 5y squared plus 20y minus 2y minus 8, like terms in the middle, so you get 5y squared plus 18y minus 8. Okay, remember you can stop the video and go back and forth. Combine like terms, we add the number, keep the term. So when you're adding, you just drop the parentheses, you would get 8 plus 5 there. So that would be 13x squared, keep the term, and then 9x minus 2x is plus 7x, and then negative 4 plus 8 is plus 4. Okay, distribute the negative, then combine like terms when you are doing subtraction. So here you would get negative 14x squared minus 2x plus 5. So I have 11x squared minus 14, which gives me negative 3x squared, negative 7 minus 2, negative 9x, and 1 plus 5 is 6. Alright, the last part here, a rectangle has a length of 3x plus 1 and a width of 2x. Find the expression for its perimeter and area, then confirm that it is a polynomial. Alright, so we have a length of 3x plus 1 and a width of 2x. Okay, so the perimeter, we add up all the sides. So we get 3x plus 1, 3x plus 1, 2x and 2x, 6, 10x plus 2. So remember, this has the same side and that has the same side. Okay, area, we're going to do length times width. So we get 3x plus 1 times 2x, distribute, you get 6x squared plus 2x. And this would be a quadratic binomial. The diagram shows an unshaded area here. So what is the area of the large square including the shaded area? So that would be 2x plus 7 times 2x plus 7. When we multiply those out and simplify, I'm going to let you do that. You should get 4x squared plus 28x plus 49. What is the area of the small? That would be the x minus 2 times x minus 2. So again, when you multiply that out, you get x squared minus 4x plus 4. Okay, so we're going to subtract the larger area minus the smaller area. So 4 minus 1. 4 minus 1 is 3x squared. 28 minus the negative would be plus that. So that's going to give me 32x. And then 49 minus 4 is 45. If you need to work that, let me know. Thanks, guys. That's Unit 1.